Creating a visual map of the elements and connections at play in a system can help us to make sense of complexity and identify the key points in a system where a problem might originate or where a solution could intervene. There are various ways to map a system, each one capturing different information and offering a different set of insights. I'm going to introduce you to 3 of the most popular forms of systems mapping, and you can find more information about mapping tools and techniques in the resources we've shared with you. The easiest and most accessible form of systems mapping is to create a basic issue map. Similar to a classic mind map, this involves visualizing the elements of a system, usually as bubbles or boxes, and the connections between those elements, usually as lines or arrows. In a basic issue map, you're not worrying so much about directional causality or feedback loops. It's just a way of capturing what's going on in the system at first glance, and it's a great first step when trying to come to terms with a problem. If you're looking to capture a bit more complexity, you might like to use a stocks and flows system map. This type of map is great when you're trying to keep track of a particular stock or amount of something and how that stock moves and changes over time. The stock could be almost anything. For example, funding, data, public support for a policy, atmospheric carbon dioxide, and plant or animal populations, just to name a few. Stocks and flows maps pay particular attention to inflows and outflows to a system. In a social impact context, this can help you to decide whether to focus your interventions on outflows, for example, if it's to draw carbon dioxide out of the atmosphere or to house the homeless, or to focus on inflows, for example, reducing our carbon dioxide emissions or preventing people from becoming homeless in the first place. Another even more complex type of systems map is a causal loop diagram. These are created by linking together a series of the directional feedback loops we've already explored, with relationships labeled as positive or negative and loops labeled as balancing or reinforcing. For example, this causal loop diagram describes a situation we introduced earlier in the homelessness space. Solutions like shelters get people off the streets in the short term, which is important. But the feedback loop on the right shows how they can also reduce the visibility of homelessness as a problem, resulting in reduced funding for long-term solutions that could find people more permanent homes. You can check out this systems map in more detail below. Causal loop diagrams like this can become very detailed and complex, but offer a lot of rich data about how a system works and where the potential leverage points in the system might be, which is what we'll dive into next.